Projectile motion. The basis of the theory of projectile motion, as stated by Shani Jennings, was originally proposed by the ancient Greek philosopher Aristotle that explained motion as an external force in the air pushed along an object, then suddenly stopped and subsequently fell out of the sky. Later in the period of Renaissance, cannon warfare was becoming one of the main weapons in war. So there was a lot of research into projectile motion. The scientists found that Aristotle's theory was wrong. Instead of falling out of the sky, the projectiles had a smooth curve. Angel Merton stated that Galileo was the first person to explain projectile motion by analyzing the horizontal and vertical components separately from the theory. She also stated that Galileo concluded that the projectile motion had two forces acting upon it, gravity and forward momentum. Angela Hartstock states that the projectile motion is a predictable path traveled by an object that is influenced only by its initial launch speed, launch angle, and acceleration due to gravity. Formulas: horizontal distance, x, equals vxt. Horizontal velocity, vx, equals vxo. Vertical distance, y, equals vyot minus 1 over 2 gt squared. Vertical velocity, vy, equals voy take away gt. Vx is the velocity along the x-axis. Vxo is the initial velocity along the x-axis. Vy is the velocity along x-axis. Vyo is the initial velocity. G is the acceleration due to gravity, and t is time. Time, t. 2Vo sine theta over gravity. Height, h, equals v squared o sine squared theta over 2g. Range, r equals v squared o sine 2 theta divided by gravity. Vo is the initial velocity. In these examples, I have used theta, which calculates along the y-axis. If you wanted to calculate it along the x-axis, you would just need to replace the signs with cos. Angle of release is very important to maximize or minimize the distance of a projectile. To maximize the distance of a projectile, it should be thrown at 45 degrees. If you want a submaximal effort, then the projectile angle must be flattened or steepened depending on how high you want the projectile to travel. It is also important to note that the projectile takes a parabolic path. So, if you throw or jump straight up in the air, it isn't considered projectile motion. It is considered free fall. Force is defined by Merriam-Webster as an agency or influence that is applied to a free body, resulting chiefly in acceleration of the body. For example, if you throw a ball, the throwing arm gives the initial force to the ball to travel in the forward direction. Then gravity is another force that is acted upon the object, bringing the ball back to the ground. Weight refers to the mass of an object acted upon by a force of gravity. Mass is defined by Merriam-Webster, the properties of a body that is measured of its inertia and commonly taken as a measure of its amount of material it contains and caused to have a weight in a gravitational field. The weight of a projectile relates to how much force is needed to project the projectile. For example, you would need a lot more force to throw a shot put than a tennis ball, because both of them have different weights/masses. Merriam-Webster defines velocity as a rate of change of a position along a straight line with respect to time. Velocity determines how fast a projectile travels while it is in flight. Acceleration is defined by Merriam-Webster as the rate of change of a velocity with respect to time. This determines the rate of change in reference to velocity of a projectile. Both these components are important components for projectile motion. To determine the speed and acceleration of these projectiles, it's important to determine the speed and acceleration of a projectile to calculate the force of the object. Gravity is a major force in the case of projectile motion. Gravity will bring a projectile back to the ground. Neville demands explains gravity as a smaller body is projected towards a larger body. The path it'll take isn't straight. Instead, it'll be a curve. After releasing a body, the two forces that are acted upon it are gravity and air resistance. But air resistance is so small that it usually isn't factored into projectile motion. So if the projectile is only acted upon by gravity, as the projectile is launched, it'll slow down as it pushes against gravity, and speed up as gravity acts upon it. Note, gravity is always a constant at about 9.8 meters per second. In action, as a cannonball is fired, a basic knowledge of projectile motion could be difference between hitting your target or missing your target completely. For projectiles in this case, you have to know that gravity is a constant, meaning that it always stays the same and never changes. Velocity and acceleration are also important as well. This determines how much force the cannonball has, as well as how far the cannonball will go, and how fast it'll get to its target. The mass of the cannonball will also affect its trajectory, and how fast the cannonball will go. The angle of trajectory is probably the most important component. If the angle is too steep, the cannonball will not hit its target. If the angle is too flat, the cannonball will also not hit its target. A basic knowledge of all these components will mean that there is more chance of you hitting your target with a cannonball. Projectile motion in sport. All sports that involve jumping, hitting, and/or kicking use projectile motion to get optimal performance. An example of this would be basketball, going for a three-point shot. The basketballer is using projectile motion without knowing it. The athlete knows that gravity will bring the ball back to the ground. They can make an estimate of how far they are from the hoop. Athlete can make an estimate of how heavy the ball is to estimate how much force they need to make the distance. They can also know the optimal release point to get the optimal performance as well as a release angle. Athlete does all of these estimations and calculations simultaneously to produce optimal performance, but these are just estimations, so sometimes estimations can be wrong and the athlete can over or under throw. Another example in sport would be high jump. You need an in-depth knowledge of projectile motion. Instead of the projectile being a ball, like in the previous example, projectile is the athlete themselves. They need to launch themselves over a bar, so they need to counteract gravity long enough for their body to clear the bar. They can make these estimations on how much force will launch them over the bar and counteract gravity. The athlete knows about how much weight and how high the bar is from the ground, so that they can make an accurate estimate. They need to also produce enough force to get over the bar. There is also known the optimal launch spot, meaning the optimal velocity and acceleration to propel themselves over the bar. Not much of an angle because they don't want to go too far. They want to go high. So their launch angle will probably be closer to 90, but not exactly on 90 degrees, because they want momentum to take them over the bar. Improvements. Let's say, for example, there is an athlete in shot put. They want to qualify for the next Olympics, but they can't throw the distance to make it. He doesn't know anything about projectile motion. The first thing I would tell him is that gravity is a constant. You will never change it, so you need to master gravity before you throw. You need to explain the path of a projectile because of the parabolic path. Then I would explain to him that the optimal release point is 45 degrees for distance. Then you would work with him to get his release point at 45 degrees. After he can release at 45 degrees, then I would explain weight and build up his strength so he will increase his force that can be converted into shot put. Increasing the force with increasing to 45 degrees will dramatically improve the athlete's throw.